Welcome back to Differential Calculus. In this video, we're going to be taking a look at the chain rule, which is the tool that we use for taking the derivative of the composition of two or more functions. Let me get my head out of the way and we'll dive right in. So, composition, we're going to be looking at f as a function of another function, u of x. I'm not entirely sure why u as the name of the second function has become so prevalent, but it certainly has. And I want to take the derivative of f of u of x. And again, if you're really interested, I'm happy to show you why this must be the case. This does fall directly from those rules of the limit definition of the derivative. But I think it's easier just to jump right to the conclusion here, which is we're going to take f prime and evaluate it at u of x. And then we're going to multiply by u prime evaluated at x. So we call it the chain rule because you chain along. You have a function inside, you take the derivative of it and you multiply it along in. If we had a deeper chain of composition, if we wanted to take the derivative of f of u of v of x, it would proceed the same way. F prime of u of v of x times the derivative of the stuff inside, which is itself a composition, so we use the chain rule there. U prime of v of x times v prime of x, and so on and so on. Let's jump right into an example here. Let's take a look at the function f of x is the square root of 3 minus 4x. We can recognize that this is a composition. F of u is the square root of u, and u of x equals 3 minus 4x. Just substitute that value of u into the thing underneath the square root, and you're good to go. And so by making that recognition, f prime of u is 1 over 2 square root of u, right? That's just using the power rule. We actually looked at that example in the power rule video, so I'm not going to go through it again, but that's just the power rule. And then u prime of x is going to be 0 minus 4 times 1, which is just negative 4, right? Relatively simple as derivatives of polynomials go. And so with that, when we bring everything together and we take the derivative f prime of x, well, it's going to be one over 2 times the square root of u of x. U of x is 3 minus 4x times u prime of x, which is negative 4. Right? The negative 4 and the 2 are going to reduce in this thing to get us to a final solution. Negative 2 over the square root of 3 minus 4x. Let's take a look at g of x equals 1 over x squared minus 9. Once again, we can look at this and realize that it is the composition of two functions. G of u is 1 over u, and u of x is x squared minus 9. Writing 1 over u as u to the negative first, it becomes a little bit more apparent using the power rule that g prime of u is going to be negative 1 times u to the negative second, or more simply, negative 1 over u squared. Then, coming over to the other one, differentiating u prime of x using the power rule again. The derivative of x squared is 2x. The derivative of 9 is 0. And so bringing these things together, g prime of x now is negative 1 over u, which is x, x squared minus 9 squared times u prime, which is 2x. Okay, again, condensing that a little bit, negative 2x over x squared minus 9 squared. You could make an argument that that should be multiplied out, x to the fourth minus 18x squared plus 81. You can make the argument that that should be factored further. X plus 3 squared times x minus 3 squared. For my purposes in this course, I don't care. I'm happy leaving things like that. So with those ideas in mind, I would like you to take a look at this expression. Right? I'm using the differentiation form instead of just saying f prime of x, but I'd like you to differentiate the function 1 over the square root of x squared plus 7x. There are a couple of different ways that you could approach it, only one of which we have talked about so far. So I want you specifically to use the chain rule and see what you can do with this one. All right, take a few minutes on that, and I'll see you in the next video.